You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast, and I have Kevin Puylaert. He's the General Manager, North America, and VP Business Development at SOPHiA Genetics. It's spelled SOPHiA Genetics. So, Kevin, thanks for coming. How are you doing today?
Pleasure. Very nice. How are you, Richard?
Good. Yeah, when I hear the name SOPHiA, I think of that AI robot, but I guess this SOPHiA Genetics is different, right?
It is. SOPHiA, actually, originally SOPHiA in ancient Greek used to mean wisdom. And so that's where the name really comes from.
Okay. So what's the premise of SOPHiA Genetics? What do you guys do there?
SOPHiA is offering a software as a service platform to democratize data-driven medicine. So we have a few applications in a few different areas, and I'd say our flagship area is in genomics. Today we've connected a bit more than 900 institutions around the world, nearly 1,000 institutions that are sharing their genomic profiles across the platform. So it means that an institution here in Boston is able to see when they're analyzing a profile how their profile compares to a profile that might have been seen in an institution in Buenos Aires or in Austin or in Paris. So we're really building a software as a service platform to be able to access a global intelligence.
Yeah, that's great because I know various companies are trying to get a critical mass of, let's say 100,000 people sequenced or 50,000, and so you're connecting all these platforms. What does that mean? How many sequences are available in the total pool?
Yeah, today we've looked at about a bit more than 300,000 profiles on a monthly basis. We see about 15,000 profiles that are being analyzed through the platform. So this is probably one of the largest consortium of institutions looking at patients at the moment. More patients are being diagnosed on a monthly basis than players like Foundation Medicine that are quite well known in this field as well.
Your platform, again, it's able to pull data from many separate platforms, but what kind of analytical tools are layered on top of that is unique to you, or is your role just the aggregation, or what else do you do?
Yeah, it's a good question. When you want to leverage on AI, it's very important to have very clean data and very structured data. So when you look into genomic information, very often there's a lot of noise into that data. So whenever we work with a new institution, a new lab that is doing clinical research, we'll go through a setup program with that lab that is quite extensive, where we'll establish the performance of that particular lab, and we will tailor our pipelines to the actual data that is generated by that platform or by that institution based on reagents that they might be using or diseases that they might be looking into. So we standardize the way the data is generated across those different labs, across those different institutions, and that allows us to share that data, or it allows people to look at data coming from a variety of places and being very comparable. And only because of that we can build tools on that data. And so one of the tools that we build is our AI is seeing how people are interacting with that data. He's seeing, okay, well, certain variants are classified as benign, some variants are classified as pathogenic, and from there is learning how to pre-classify similar type of variants. So it will suggest, okay, well, maybe those variants are more likely to be pathogenic and those variants are more likely to be benign. It makes it very easy for the user to test additional profiles.
Are you just looking at human genome, or are you looking at viruses or other creatures?
It's a good question. Yeah, we look only at humans at the moment and really focus on the clinical research space.
Yeah, because if you're able to establish data standardization and you're aggregating it from many sources, some other company or some other effort could take that and do the same thing for viruses or for plants or for whatever else they want to catalog, and you'd have all the infrastructure set up for them to do that probably much better than they are right now.
Yeah, no, that's true. I think what is essential when we're looking at humors, and in particular today we do many cancer samples. You want to be able to find an answer for each and every profile, whereas when you're looking at plants or when you're doing research, coming to a solution is not as essential. You might be able to look with another plant, or there's the stakes are not as high as when you're looking at a cancer sample, and you want to make sure that you're finding the causative mutations, and as such to be able to recommend certain treatments for that patient.
What are some interesting correlations or findings that you're seeing in the data, because you have access to so much of it?
So one of the interesting things we saw when we were observing how our AI was growing is that in particular diseases, for example, in hereditary cancer, we realized that after we had seen 30,000 samples, our AI was 98% as good as a human doing the pre-classification. So it means that it's saving people a lot of time for the routine cases and letting them focus more on difficult cases.
Okay, so all right, so 98% in determining what?
In determining that a particular sequence would be pathogenic in a particular sample.
Oh, okay. So you're looking just at the genome, or you're looking at, you're looking at DNA or RNA, or you're looking at proteins or, molecules, or what are you looking at?
Yeah. So we're really there to offer tools for whatever labs are using at the moment, for whatever is established in the field. And so what we're seeing is that DNA is very prevalent. So there's a lot of DNA testing. RNA is starting. We see quite a few labs starting to look at fusions and inversions with RNA. And so we've mostly been focusing on those two applications.
Okay. All right. So you're able to tell again if a certain gene is associated with cancer, if it's an oncogene, I guess, and what kind of insights with the RNA and the other insights you're getting?
Yeah. So I think in cancer, so we have two main in the genomic space. You can look at Mendelian disorders, so hereditary disorders, or oncology. In oncology, we're going to associate certain treatments. We will be able to associate certain clinical trials. We will be able to give some prognostic information based on the variety of mutations that we'll find in the profiles, be them from DNA or from RNA. And if we look into Mendelian disorders, there we'll be able to see, okay, well, this is the causative mutation. This is most likely the disease that the patient is suffering from based on the genetic profiling that was done for that particular patient.
Yeah, what about taking it further, though? I mean, does this tell you or give you any insights into how to assist with drug discovery, or how to find, immunotherapies or other kinds of therapies for cancer?
So yeah, definitely therapies it will recommend. Today we haven't done much with respect to drug discovery. It's been mostly used really in the clinical research space that are mostly trying to diagnose certain samples immediately, right, rather than doing retrospective studies.
Okay. So what are some of the goals for the next year or two? Do you want to get to 1 million genomes on file, or what's the big goal?
Yeah. So as I mentioned, our flagship area is genomics, but we started now about 6 months ago. We started to invest significantly in radiomics, where we do the analysis of radiology images, and we invest significantly in what we call trial matching. And so all of this is in line with our long-term vision of building data-driven medicine and of finding as many sources of data as possible about that characterize a particular patient, so that you can say, okay, well, this profile looks like so many other profiles we've seen around the world. If we make it more tangible, this profile looks like 50,000 other profiles we've seen that are very similar, a cluster, and out of that cluster, 30% have had treatment combination A and B with outcome X, 40% have had treatment combination C and D with outcome Y, and so the oncologist has a lot more data in hand to be able to give a very precise recommendation with outcomes.
So, any surprises about the prevalence of certain cancers or other conditions?
I think at this stage of development, we reflect quite well what is the prevalence of different cancer types around the world. So no particular surprises. I'd say there. No.
Oh, so the prevalence of certain conditions, does it seem to follow any pattern by country or by age or gender, or are you seeing those skews in any of the conditions you're looking at?
To be honest, I don't know. We're quite sensitive to the way we use the data that is being analyzed through the platform. So we're originally a Swiss company based in Lausanne. With now headquarters in Boston as well, and so the data privacy is very important to us. So we can only use the data that is being shared through the platforms for certain very well defined goals. And so we haven't done that many studies of that kind.
Okay. So again, what is the goal over the next year or two? Where you want to take things?
So we're seeing a phenomenal growth at the moment. We're now seeing about 15,000 patients a month, and we're seeing that number grow at least 50% every 6 months. So today we're really trying to onboard as many institutions as possible to participate in this effort, because if you look at Mendelian disorders, the diseases that we're studying are very rare, and so you need a very large set of profiles that are being shared across the community if you wanna infer something smart for the particular profile you're looking at the moment. So today we're really in a phase where we're onboarding institutions and making the community grow.
Any learnings that you're getting about the need to standardize data? Are you talking to companies that actually do the collection of the DNA and saying, hey, don't forget to do this or to test that or to add this in, so that the standardization is easier or more complete?
Yeah, it's a very good question, because it's something that is really underestimated in this industry, but I feel in most industries that are speaking about big data and about data collection. People don't realize how important it is to have standard and very clean data to be shared. So I think the way we've grown is by being exposed to a variety of institutions that were all giving us or had their own experience. And so we shared that experience from all our users across the community in terms of how to generate the cleanest data. And today, during our setup program, this is one of the essential parts of what we do, is in making recommendations to our users into how they can tweak their lab to get the optimal data. If we speak about genomics, but in a similar way about in radiomics, where different users are looking at the same images from the same patients over time and not always structuring the data in similar ways. So it's very important to have tools that structure the data, that make sure that they extract the tumor in a similar way for that same patient over time, no matter who is looking at the image, so that data can then be compared, and so that you can have some intelligent findings on those images.
I would think, as it relates to images, I've spoken to a few companies that are, increasing the quality of the images, the resolution, etc. Do you keep tabs on, you're getting data, but the quality and the nature of that data may change over time. And maybe if you communicate, I'm sure you are, but if you communicate with some or all the data providers, you'll find ones out there that are advancing in certain ways. Maybe there's a new compression algorithm for it, or again, a higher resolution for an MRI or something.
Yeah. So in genomics, which is a field where we've been now for a few years, we have very close discussions with some of the large reagent manufacturers, and we have partnerships with many of them, where we're feeding back some of that information, some of the knowledge we gained in standardizing the data across so many labs. In radiology, we're having those discussions with large imaging providers. We try both in genomics and in radiomics to start from the raw data, so to not have too many layers between us and the actual instruments. But we haven't. It's a very the fields are moving at a different speed in terms of the machines that are generating the data between genomics and radiomics. So we haven't had that much influence in the radiology field yet in making sure the MRIs or CT scans are evolving in ways that would make it easier to standardize the data.
Yeah, I just figured if anyone's going to see it first, it would probably be you, because again, you're connected to all these places that are doing this imaging.
Yeah, you're right. It's something we should be exploring in radiology.
Okay, well, very good. So, what's the best way for people to learn more about SOPHiA Genetics?
So we have a nice website. It's SOPHiaGenetics.com. So SOPHiA Genetics.com, where you'll find a lot of information, and from there you can ask for us to reach out as well for a chat. Or we're in most conferences around genomics or oncology, both nationally but also internationally. We now have users, I think, in over 70 countries. So with a presence that reflects that as well.
Okay. Well, very good. Well, Kevin, thanks for coming on the podcast. I really appreciate it.
My pleasure, Richard. Have a good afternoon.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.